people might imagine. Do you have any kind of specific timetable for when you're hoping that the Army will acquire these types of systems, and what are some of the technological hurdles that are kind of stand in the way of that coming to fruition?
Yeah, so that's a great question. So, right now, let me kind of explain to you where we're in the process. So we know that we have gaps, and we are validating those gaps, and we have requirements that we are validating right now. And we are moving through the process to have those gaps validated. We're going to move into a evaluation of alternatives. We're going to start that here soon. That will take place over the next 12 to 18 months, and that will inform not just our requirements, but also the technology that is available, and also the approach that we should take to bring the STE, which is synthetic training environment, to reality. And so it's through that analysis that we do that we will determine, what comes in when, what should we go after, and how do we bring all of this technology to bear. So the time period, starts from now, and we look at this happening in the 2025, 2030 time frame, and then we will work our different simulation environments. Based on the analysis, we will determine when to bring that in. Does that answer your question? I would say 2020 to 2030, okay? Because some things may come in sooner based on what I'm seeing. Any other questions?
Second part of my question was, what are some of the technical hurdles to going from the technology available now to having the system that you're hoping to field for soldiers?
Yeah, so I think some of the analysis is going to show that. But for example, one of the things we have to look at is how do we replicate terrain? How do we rapidly generate that terrain to get that common terrain that we want in all of our simulations? So that is a challenge all in itself. But there is some work that's being done in the S&T community and also in academia, and I actually seen a lot of our partners out here in AUSA that's actually pursuing that. And so, we have to figure out how do you get that terrain that replicates the world. That's a pretty big, tall task if we want to train where we potentially could fight. We're also looking at what is the gaming engine and how does the gaming engine look. But when we look at the S&T and where that technology is right now, we think that we're on the mark to bring this in the time frame that I told you. But I also need to understand what the analysis is going to show me. Okay. You got one back here. I'll give you a break for a second.
Hello. Lance Milstead, Soldiers Broadcasting. With some of the things that have been talked about with multi-domain and echelon, will this also include training simulations with our allies at the same time as we're doing it with our forces in the States?
Yeah, no, and that's an excellent question because that's one of the things we're trying to get at. We understand that interoperability is one of our challenges. So we think if we can go to this common architecture, that we think we can mitigate most of those challenges that we have. And if you think about it, even today we're able to do that with some of our partners already, but it's at a high cost, building bridges, doing things like swivel chair operations. But we think if we get this right with a open architecture, we can resolve a lot of those challenges. Sir, did you want to? So this is a
asking the question about what technology, I'm Mike Lundy, I'm the CG out of CAC, but you asked the question about what some of the technological challenges we're going to have. I think some of the other areas that we've got to look at, since we've got a lot of industry partners in here, is how do we get simulations to run on native software. So we put software in aircraft, tanks, everything has software now, and what we're forced to do today is go back in and reverse engineer that software to get it into simulation. And what I want to be able to do is take software right out of the vehicle, right out of the aircraft, put it into a simulator, and then it's up to date, and we don't have to go back and re-engineer all that. It's very expensive, it's time consuming. The terrain piece is the same way. It's not just our ability to build that terrain, because we can do that today, but it's very expensive, it's very time consuming. It takes anywhere from 6 to 8 months to build a 40 by 40 kilometer terrain that's fully virtualized and works in all the different simulations. So again, getting after how do we do that? And I think the Institute of Creative Technology is doing some good work for us, where they can look at data points and they can synthesize as it goes across the DTED. So there's a lot of different technological hurdles that are out there And really, we will, as a part of the AOA, as we get the requirements approved and we get the AOA guidance out there, that's going to be one of the things we're going to put together is an S&T list of those things that we need industry to help us understand and when we need those and what TRL levels we'll need those at. And that'll be forthcoming within the next 60 to 90 days. So, last, well, yeah, it's things like when we talked about the interoperability piece, you know, today many of our partners, they purchase the simulations that we use. So if you go over to Europe, you know, most of our partners over there are using JCATS, which is our constructive simulator or simulation that's at the joint level. So we do have joint protocols and joint standards. And so one, we're working very closely with the J7 team to make sure that as we develop the STI, that we use them on the joint standards. So our coalition partners have an expectation of the direction that we're going to. But as we look at affordability, and affordability is a big piece of the synthetic training environment. If you look at, you know, AVCAT and Close Combat Tactical Trainer, the two virtual sims that we have, and RVTT, those are very, very expensive solutions. They're pretty exquisite. They're self-contained. They're in tractor trailer trucks or in big facilities, and they have a very high level of fidelity. Frankly, probably more fidelity than we need to train at the collective level. We don't want to have negative training. We don't want to have very, very low fidelity. We want to get the fidelity right. So we're doing studies right now on how much fidelity we need, because fidelity directly correlates to cost. And cost and fidelity also correlate to how big something is and how hard it is to move around and how expensive it is to maintain and how many contractors. So we're going to get the fidelity at the right level to get collective training, because these are not system trainers. We're not teaching somebody how to drive a tank necessarily, but we don't want to have negative habit transfer when they are in there driving it in simulation. We're trying to teach them how to fight a collective group of tanks or a collective group of aircraft. So fidelity is going to be a key driver that will help us keep the cost at a reasonable level, help us, which will also allow our partners to participate and possibly purchase these, because frankly, you know, an AVCAT trainer or CCTT is very, very expensive. So we can get after interoperability by making it more affordable, more appealing to our partner nations that are out there. So,
thank you, sir. Is there any other questions?
This, but if no one else is going to ask, I've got some more. To what extent does the gaming technology that exists and that is emerging enable you to do more than you're doing now? And how does that differ from LVC training, or is it sort of part and parcel of that?
How does that differ from overseas training?
No, the gaming solutions. How does that differ from LVC, or is that actually just part and parcel of LVC?
It's actually part and parcel. You know, right now we rely on the gaming VBS3. We utilize that intensively in our training, and also to provide that capability that we have as part of the live virtual constructive piece. And it will be prominent in our future synthetic training environment, because we think that the gaming piece will be a key piece for the engine piece that will allow all of this to run. Okay. Any other questions, comments?
For one thing on the gaming, you know, today our gaming environments are very small. Gaming is kind of a combination of virtual and constructive combined together. So again, it's kind of a precursor to the thought or the concept of STI, is how we start to integrate these capabilities. But today, they can only work in small areas because the fidelity is much higher. So as we start to drive the gaming industry, and, you know, we started out in VBS 2, you know, the box that we could fight in, the virtual box, was very small. VBS 3 expanded that box, but again, it's still limited by, you know, scale. And so we're trying to scale this to the world. So we're asking for a pretty big solution. So again, that's why it's going to have to be cloud-based. It'll have to be compartmented to where you can just go in and pull out whatever piece of the world you want to fight in. But again, that's what we're driving the gaming industry to, is to where you can fight over larger pieces of terrain, that we virtualize more of the world. And we got to think of different ways of doing that than manual, because basically now we have to go in and manually virtualize the world. So again, those are some of the challenges that we're pushing from an S&T perspective. But gaming is certainly probably going to be the engine that drives us in the future. But the difference between that and the virtual piece is really the size and the scale and the fidelity.
So, ladies and gentlemen, I first like to thank you for taking time out of your busy schedules to listen to the synthetic training environment. I would ask that you keep your ear to the ground because you're going to hear more and more, because we really want to bring this to fruition, because we think it is going to revolutionize Army training, and it's going to help build readiness for the Army. So thank you very much.